Hello everyone! I'll start my presentation now. Welcome to ElixirConf. Summary. This talk shows how we create a casual and minimalistic website of Cobra EX, a local Elixir community in Japan, with Phoenix and publish it. I will inform a URL of these slides for my talk later by tweet. This talk focuses on the next process for casual and quickly release a minimalistic Phoenix website. Prepare the Phoenix project by Noecto with Docker. Adapt CSS layout by Tailwind CSS. Put it on Heroku path to release the website to the public. Prepare to build CI and CD to make operations easier by using Circle CI via GitHub. The following is actually implemented and executed, but much of the explanation is omitted. Operate Git management. Implement markup HTML. Implement tests. The diagram of this system. The GitHub remote repository URL for this project we have implemented is here. About me, Ryotaro Imahashi. I live in Kitakyushu, Japan. I'm a web developer of Pixiv Incorporated and an organizer of Cobra EX, a local Elixir community in Japan. Pixiv Incorporated provides a variety of services to support creators, centered on the illustration communication service Pixiv. My favorite contents. My another activity. One of the Japanese traditional martial arts Daitoru Aikijujutsu. About Cobra EX. Cobra EX is a community that promotes the Elixir programming language and its web application framework, Phoenix in Kitakyushu, where both high-speed processing performance and high development efficiency can be achieved. Moku Moku Tech Meetup, which is a hackathon where each attendee acts alone toward each goal in Relax. Kokura EX Radio, every Wednesday from 8:30 a.m. to 9:30 a.m. Japan time, on air at Twitter Spaces in Japanese. This is an audio distribution program from Cobra EX. The program focuses on new IT topics, including those related to the Elixir development language. There will be a question and answer corner for listeners and text-based information sharing on the Cobra EX channel in the Elixir.jp Slack. Though we talk currently on the radio in Japanese, we are welcome English speakers and will try to interpret both in English and Japanese. OSS contribution. Cobra EX and Pele may meet up a Japanese Elixir community, try to contribute OSS officially and X, Elixir, and Beam Awesome, which realize high-speed processing performance. Chapter 0, checking the development environment and beginning of the story. The verified versions of this talk. The development machine for this talk is a Mac Intel version Big Sur, and each verified versions of technologies are as follows. Elixir 1.20, Erlang OTP 24, Phoenix 1.6, Node.js 16.9, Tailwind CSS 2.2. Phoenix 1.6. Phoenix 1.6. Now let's start with the contents of this talk. titled with Elixir's Adventures in Phoenix Land, introducing the main actor. Elika, an Elixir Lava developer, she wants to create a tech community site casually. Wireframe of the site, wishful thinking. I wanna make it much quicker and easier. I wanna operate continuous delivery with ease. By the way, I've never used the Web Phoenix framework, but I heard it's nice for this situation. And the Phoenix version 1.6 was released the last month. It's perfect timing, isn't it? Okay, let's start Phoenix 1.6 with me. Chapter 1, Setup of Phoenix 1.6. What this chapter covers, we will run through the process from building the Docker development environment to building Phoenix and displaying the first Welcome to Phoenix screen. Now we will make the Phoenix 1.6 project directory and prepare the Docker files as shown on the right. About the project directory, we named Kokura.ex this time. Prepared Docker file, Docker compose.yaml and Dockerfile is here. It specifies Phoenix version 1.6. After prepared Docker files, let's execute Docker compose build. After done of Docker compose build, install Phoenix 1.6. We saw the following message and congratulations, the installation was completed, and at the moment the directory tree is shown on the right. After Phoenix installation, fix IP to 0000 for div exs file by update as below. Now we execute Docker compose app and look localhost colon 4000 in browser. Yes, we did it! We got the proof that the screen showed up Welcome to Phoenix. The first mission was completed. Chapter 2, Adapt CSS Layout by Tailwind CSS. To prepare the layout with ease, we will use Tailwind CSS. In this section, we will focus on the setup and introduction of Tailwind implementation. We will also explain website content creation and page transitions, but we will not explain much and skip about markup, tests, and other implementation details. Why we chose Tailwind CSS? The main reason is that by adopting Tailwind CSS, a Unity-first CSS framework, we will be able to make good progress in our mission to quickly set layout styles without writing raw CSS. Tailwind CSS requires the environment of Node.js, but our Phoenix 1.6 version project does not have the one yet, so we must add the step of installation Node.js in Dockerfile. In this talk, we use npm package n to install Node.js and manage the versions. There is also a reason why I want to specify even minor versions of Node.js and avoid problems caused by version differences. After installing Node.js, we rebuild containers again with Docker compose build. For setup Tailwind CSS smooth, we simply choose hex package phxgen tailwind. This builds up Tailwind CSS development environment to a new Phoenix 1.6 application nice and quickly. Big thanks to the Hex project owner Kevin Lang. The first step to do is to stop running containers and then update mix exs as shown on the right. After that, we do mix deps get and compile. Then execute the command docker compose run app mix phxgen tailwind. Now we are ready to implement CSS with Tailwind. The main files where the differences occurred are shown on the right. Now let's start rerunning containers by docker compose app and check results in our browser. With the implementation environment of Tailwind CSS in place, the default CSS style of Phoenix has been removed. Now let's try one implementation of Tailwind CSS from this state. Add the classes prepared by Tailwind CSS in the h1 tag by inline style. This magic has the effect of converting the font weight, font size, and color of fonts to whatever we want. Now we will start implementing the content setup and page transitions for our website CockroachEX. Page transitions are shown below, and the implementation is done as shown on the right. The example shown here is for the About page, but the implementation for the Event page can be done in the same way. Please note that we will need to stop and restart the container as needed. Let's take a look at the About page, which has just been born. It is in a plain state with no CSS classes applied yet. From here, we create the content, including text and images to set the layout. We won't go into the details here. I will cast a Tailwind CSS spell. We will let you know the results soon later. Let's look forward to it. Chapter 3. Put it on Heroku to release the website to the public. What this chapter covers: Heroku is a nice path for easy application release. It supports Elixir, of course. Our website is built on Docker, and we will try to deploy it using Heroku's container registry system. Why did we choose Heroku? It's because, in a nutshell, we are used to using Heroku paths. So let's start the setup. Setup in progress. Oh no. Hey, wait a minute. I think I caught a glimpse of the path that looks good. Fly.io? Oh dear. No, I did not say anything. I've already started to build it on Heroku, so I'll release it there and then build it again on Fly.io. Anyway, let's go back a little bit and start with the setup in Phoenix for release. We first need to create our secret key by running the command docker compose run app mix phxgen secret. Two secret key generated by this step is the one we'll need to deploy to Heroku later. Make a note of it somewhere so we don't lose it. This is confidential information. Please don't reveal it to anyone. Also, update our Docker file and relevant files as shown on the right. Please note that these changes may prevent our local Docker development environment from running properly. If so, we should take the following steps. We write docker compose.yaml as shown on the right, with secret key base being a long dummy text of your choice. We can also remove the secret key base line from app config div exs. In the future, it would be nice to have two Docker files, one for development and one for release. We omit an explanation of that here. Oops! We forgot one more important thing. We should create a Heroku.yaml file and put it in the root of our project directory. Now it's time to set up Heroku. Let's log into Heroku from the terminal. Now let's create a Heroku project by executing the command Heroku create awesome app name. In the awesome app name field, we should enter the name of the application name we want, and this string will be directly incorporated as part of the application's public URL. At the same time, it will register our Heroku repository to the git remote repository. Check it out in the git remote command. We'll also need to add the secret key we created earlier to the Heroku environment variables. Let's register by execution the command Heroku config set secret key base. Now let's get ready to deploy a Docker-based project by using the Heroku container registry mechanism. For a more detailed explanation of the Heroku container registry, it would be a good helper to read the official documentation. Here we will focus on the execution steps. However, it is very easy to do, so let's run the command on the right. Heroku stack set container. Ensure that our code is all git committed, and then run the command git push Heroku my branch main. This will push our files including heroku.yaml to the remote repository of Heroku. Once we've done this, move to the app directory, and it's time for the production release time. Run Heroku container push web and Heroku container release web. Unfortunately, if that doesn't work, what do we do? The command Heroku logs tail will help us. Check our logs and try to solve the problem. The cause of the error might be, for example, you might not log into Heroku by Heroku container login, so the error around auth intercepted you. You might omit the environment variables related to Heroku, either on Heroku or in our Docker file. You might forget to git push Heroku the changed files. We will assume that everything went well here. Now let's see the site published for the world to see. We can run the Heroku open command to display the site in the browser. Open Sesame. We will let you know the results soon later. Let's look forward to it. Chapter 4. Set up CI and CD by using Circle CI. What this chapter covers. For the concluding part of this talk, we'll build the CI and CD pipeline. The CI and CD pipeline will bring to make operations easier for us. In this case, we will build the CI and CD pipeline by using Circle CI via GitHub. This section will mainly focus on the explaining the flow of the CI and CD pipeline we built. but we will not explain much and skip detailed explanation of Circle CI, GitHub, and CI/CD themselves. So we will go through the process step by step, but we will not explain how to create a Circle CI account. Furthermore, we use GitHub, but we do not explain how to connect the remote repository to the Circle CI site in detail. We can find detailed instructions on these topics on Circle CI's official website. Here is the URL for those. Circle CI has good technical documentation, so we can find out and solve most problems by reading their documentation. Let's start by writing code into the Circle CI config.yaml file. The main points of the process flow are also described in each section. We will also include reference URLs. Executors. By applying machine to the executor type, we run the job in a Linux VM image Ubuntu. In addition, the machine executor gives us full access to the Docker process. This allows us to build and run custom Docker containers. Orbs. To easily set up the Heroku deployment process, we are using Circle CI's Heroku orb. Circle CI orb is a shareable open source package that brings together building blocks that make it quick and easy to integrate and process different services. Workflows. Once the container image has been built by the build job and subsequently merged into the main repository, the development process is executed. The implementation is reflected in the production environment. In the build job step, various build operations are executed as the name suggests. In this step, testing and formatting checks are also carried out during this stage of the process. Persist to workspace, files, and directories required for development are shared via workspace between the build and deploy jobs. Deploy. This is where the process of deploying to Heroku takes place. The environment, variable, settings, etc. are described later. Go into our project Circle CI dashboard and set two environment variables. One, Heroku app name. This is the name of our Heroku application that was decided by the Heroku create command. 2, Heroku API key. In Jira we get the authentication token with the command Heroku authorizations create and register the generated token to our project's Circle CI dashboard as Heroku API key. Now, all we have to do is git push to the remote GitHub repository. When we push to our development branch, only the build job runs. Once the build is complete, we can merge it into our main repository. After we did the merge operation, both build and deploy jobs are running. Now we finally have a pipeline that updates our production environment with just a git push. The deploy pipeline is almost finished and the green light has been turned on. Ta-da! We will let you know the results soon later. Let's look forward to it. No, we are not. Now it's the right time. The time has come. This is it. Yeah, we did it. The first goal we set, we were able to accomplish smoothly. And we hope to grow it in the future. I imagine such a future tech meetup, real-time code sharing, event notifier, blog, chatting, real-time code sharing, real-time, of course, live view, right? With live view, it will be easy and smart to create real-time code sharing on it. I can't stop dreaming. Alright, I'll release a lot of features in the Phoenix framework. Let's do it. I love Phoenix. I love Elixir. I love Fly.io. I haven't used it yet. Imagination is the only weapon in the war against reality. Isn't that right, Cheshire Cat? And our friends, we are all allies who uses Elixir to refine our imagination and ride the phoenix from the land of imagination to the real world as well. Thank you for watching. Thank you very much. Thank you very much. Bye bye.